Trick to solving this problem is by noticing that all these numbers follow the Fibonacci sequence. If we started with n equals 1, we would see that there is only one way to climb that staircase, which is with one step. And then we are given an example 1 that when we have n equals 2, we have two ways to climb. And then when n equals 3, there are 3 ways to climb. We could continue this sequence because if n equals 4, we would have 5 ways to climb if we were to list them out, because we would have the possibility of climbing one step, one step, one step, one step, and then we can do 2 steps twice, and then we can do everything in when n equals 3, where we had 1 step plus 2 steps, and then we would add another 1 step, and then ditto for this third possible way of generating 3 steps when n equals 3. So following the Fibonacci sequence, we can basically solve this problem similar to how we solve Fibonacci, which is using a while loop with temporary variables to achieve memoization. And having the temporary variables in the loop is much better than the recursive way of solving Fibonacci because it reduces the runtime to O of n instead of having to do 2 to the n when you make 2 function calls each time. So if we write this up, we can have 2 temporary variables holding the previous 2 values. So we can start with our base cases. So if n is equal to 1, then we just want to return 1, as we know there's only one way to climb that staircase. And then if we look at temp 1, and then we have temp 2 equals 1 as well, then while n is greater than or equal to 2, because this is not covered in our base case, we want to sum up to find what our value should be by summing up the previous 2 values, which is what temp 1 and temp 2 are going to be. So we can basically have temp 1 be the sum of temp 1 and temp 2, which is going to give us our most recent value. So we're just in the plus equals with temp 2, and then we want temp 2 to be the value of temp 1, so we can keep on moving forward and summing up the previous values. So to do that, we can have temp 2 equals the current temp 1 minus temp 2, which is going to give the previous value of temp 1. Now, at the end, we also want to decrement n just to make sure we don't run into an infinite loop. And at the very end, temp 1 should be our most recent updated value, as it is the one that's getting incremented and summed up earliest. So we're going to want to return temp 1 at the end. That's going to be the value corresponding to the nth number in the Fibonacci sequence. So let's see if this works. It looks pretty good. So there you have it. This problem is essentially Fibonacci, but like a word problem version of Fibonacci.